All right, stop. So once again, this is called hop on top of the towel top. And what you just saw was kids actually doing the assignment or doing the activity. Now, some kids got a head start, some kids didn't, because I wanted this to ease into initial value. I want to start that discussion right now. And just asking kids, all right, before we begin, do you think those that have a head start, does that mean they're going to necessarily win, or will they have the fastest rate? And I just want the kids thinking prior to the activity, and then when we return in class to finish the activity, it made it a lot easier for kids to make connections. So as we progress through the worksheet, now of course they did the table using their rate, and they also completed the graph. Now what I had students do after they did the table and the graph, they had to write a linear equation that represents their table, and I had kids share that equation with me, and I transferred it to Desmos. So with this group, I put it on Desmos and asked them, all right, does this graph look similar to the graph on your paper? What do you notice about the graph on your paper and the graph on Desmos? Well, they both cross at 5 on your y-axis, or the y-intercept is 5. So, okay, if the y-intercept is 5, let's think back to the activity. How many hops did you start ahead? Well, I started 5 hops ahead. Then we started talking about initial value, starting point, and it made it so much easier when I was able to make that connection. And we did that for every group, and we did it one at a time, because what I wanted to do was, and what I did was, I wanted kids to see all this and compare them. And then I asked kids, okay, looking at this, which group walked or hopped at the fastest rate? And it was beautiful. They was able to say, well, it was this group with a rate of 6.9 because they had a greater rate. Now I asked them, all right, well, they had a greater rate, but they didn't have a starting point or initial value. Did that make a difference? No, the only difference made was some kids got a head start. But as you can see on Desmos, if this group continues at this rate, they will surpass the others. And if you keep going, it will close out on this green line. Now, and as you can see, purple win. And this also led to discussion about systems or linear equations, where I can show, oh, what does this mean? Well, in about 8.6 seconds, both of these groups will be at the same number of hops. But when you keep going, the purple line definitely exceeds it because once again, it has the greater rate. And going to the worksheet, the last question. Using your own words, how we define initial value from a table and a graph, they had to look at the table. And they noticed that, okay, when I have an input of 0, that output is my initial value or my starting point. Now, how does that look on the graph? Well, that's my y-intercept. Where the line crosses my y-axis, well, that's the y-intercept or the initial value. So it's pretty cool just manipulating these equations, letting kids see it in different forms, letting kids see it compared to other equations where they can see what's going on for themselves. So I'm not telling them explicitly, they're noticing it themselves, which is more beneficial.